Hey everyone, welcome to the channel. This video will be the first in a series that will cover the fabrication of an airbox for this KJ Raycing crosskart. I am by no means a professional manufacturer, so what you're watching is just a do-it-yourselfer who enjoys making things, learning about new technology, and trying to apply that to the automotive hobby. Alright, let's get started. As of right now, the plan is to make this airbox out of carbon fiber, but I'm going to be experimenting a bit to determine how this will ultimately go from what you see here, nothing, to a completed airbox. This video is my attempt to see if I can start with a 3D scan of this Gixxer 600 motor in its home and be able to use that scan to make either a 3D printed mold that I can use to either build the airbox or maybe just 3D print a mounting flange that will attach to the airbox in some way. So the goal here is to scan your object. In this case, that's the Gixxer motor and the crosskart, and the scanner is going to be gathering data points to generate something called a point cloud, and that ultimately will become your 3D model. So you're seeing, as I'm scanning up in the top right, the data points are being generated inside the software. So orange areas are areas that you haven't gone over enough to be able to give the software enough data. The green areas are areas that it does have enough data to be able to generate that 3D model. So you want to continue going over it till everything's green. You want to change all the orange into green. I'm over on the laptop now, grabbing areas that the scanner picked up that I don't necessarily need. So I'm going to be going through with a clipping tool and just grabbing some of those data points and deleting them from the point cloud. You can see now that the scan is over, there's still some orange areas, which is okay. These are areas that are probably going to get filled in with the second scan anyway. So we'll do another scan coming up with the radiator on. The reason for doing one without the radiator and with the radiator is just to be able to maneuver the scanner, get that in closer to the motor without the radiator obstructing that. So while I'm getting the laptop set up and before we jump into the next scan, I just wanted to give a shout out to Kyle Frederick, who's the guy in the video here with the beanie on. You'll probably see a lot more of Kyle in these videos as well. Kyle is the guy I spend a lot of time building stuff with, carbon fiber panels, welding up cages and things like that. So Kyle's big into the hobby. And if you ever wanted to know what Jesus might have looked like riding a skateboard, you could look up Kyle's Thrasher part from many years ago. Or I can just show it to you here. Sorry, Kyle. Here we go with the second scan, and it's going to be exactly the same as the first scan. This time we just have the radiator in place so we can model around that when we need to. What's nice about this scanner is it has a button on the back you can use to pause your scanning. So if you're in an awkward position or you need to move to the other side of the object, you can pause your scan and it will give you the opportunity to restart it. So it'll pick up on specific data points that it's already gathered and reorient to try to find its tracking again, but it'll be able to pick up on wherever you left off. You'll see as I'm scanning, I'm going closer to and further away from the crosskart. The reason for that is the scanner wants to stay at a set distance away from whatever you're scanning. So when you get too far away or too close, the lights on the back of the scanner change colors. You can kind of see that in the video. And the software is also giving you a prompt, and it's telling you whether you're too far or too close to the object. We'll speed this part along just because it's the same as what you've already seen a lot of throughout the video. But this is just me wrapping up the left-hand side of the crosskart, just taking the final scan on the left-hand side with the radiator installed, and then I'll jump into the software just to make sure that I've hit all my points. Here I am looking over the scan, and as I mentioned before, you're looking for green here, so you want to see more green than orange on the points that you want to keep. Orange is just going to have a tough time trying to extrapolate that data and turn it into a 3D model. Following my little spin move there, I'm jumping into the right hand side of the crosskart and taking the final scan, and we'll finalize the second scan with the radiator installed, and then I'll take the first scan without the radiator, the second scan with the radiator, and then use the OnStar software to mesh those two things together. Those two models will be combined together to create one model. Here's the final outcome here of the scan with the radiator installed. You can kind of see in this second scan too, the engine detail is not as strong as it was in the first scan. That's the reason for combining the two scans. I'm going to pull our original scan without the radiator, and you'll see both scans are going to show up over here on the left hand side in the project list. You can see the first scan now without the radiator shows up in the project list, and the second scan with the radiator is also there. The two overlap, so we need to use a tool within this OnStar software to align the two together. The project alignment tool gives us the ability to take each of our scans, so we're going to choose the scan without the radiator and the scan with the radiator and combine those two together just to make one 3D model. So this tool has either an auto feature alignment or a manual alignment. We're going to use the auto feature alignment, and it's going to take the cage, most likely. It'll use the cage as its basis between both of those scans, and it's going to align those two scans together using that cage. I'm pretty happy with that. So the next step is going to be to mesh the model, and you'll be given a bunch of parameters to get more detail out of the 3D model that you're going to make. So I won't go through each of those different options, but once you're through that process, you'll have finalized your 3D model. So you'll have gone from the beginning of the process to a full 3D model that you can pull over into Fusion or SolidWorks and use that now to start building your Airbox. Alright, well, I'll wrap this video up with a couple final thoughts. The first is the most important. Your computer should definitely exceed the minimum requirements for your 3D scanner. Most scanners are going to have, all scanners are going to have a GPU requirement, memory, things like that. So just look for something that exceeds that. If you go with the bare minimum, you're going to run probably at the ragged edge of what your computer can handle. So you'll be maxed out. That was the case with the laptop that I was using. So look for something that exceeds those minimum requirements. Next is to start scanning in an area with unique features. This will help with tracking. So if your 3D scanner loses tracking, you'll have something unique that you can point the scanner at and help it reposition if you lose tracking entirely. Last is to avoid dark surfaces. So the 3D scanner might have difficulty capturing definition in darker areas. So you might have to consider putting tracking dots or some of the sprays, some of the matte sprays, spraying your object down with matte sprays to help the scanner recognize what it's looking at. Thanks for watching. I'm always looking for inspiration, so if you got something to share, a project you're working on, don't hesitate to leave a comment below so I can check it out.